All right, so today what we're going to be working with is actually making physical changes to the graph, to the parabola, to the shape of a quadratic. We want to see what happens to the parabola when we change variables A and C. Now, once again, I showed you this page. This is your formula chart from the STAR test that you're going to get on the day of the STAR test. Which one of those formulas or which one of those equations out of the first two have the variables A and C? Which one out of these two have A and C? Which one? Yep. Standard form has A and C. These are quadratic, well, quadratic formula has it, but I said A and C, not A and B. So A and C, we're going to be working with standard form today. We're only going to be changing the values of A and C. So we're basically going to be ignoring BX, okay? So let's go ahead and write standard form of the quadratic equation. We've written it before several times, but let's go ahead and write it one more time. And there is one feature that you should be able to identify based on just that equation. Which one is it? You should be able to tell me one part of the graph. You should be able to tell me what C is. What is C? C represents the y-intercept. Just keep that in mind as we're going through this. C represents your y-intercept. Correct. Because we've gone over that in the past. We're going to see what happens if I actually change the number, the value of C. Now your parent function is y equals x squared, where there is no number in front nor behind the x squared. So if there technically is no number in front of x squared in the parent function in your original parabola, what number would that be? If you don't have a coefficient, if there's no number in front of a letter, it would be the number 1. But notice how C is added to the very end. What can I add to the end of this and it won't affect it? Plus 0. I don't know why I wrote minus. Plus 0. So that means that C, or my y-intercept for my parent function starts at 0, but the value of A is 1. I gave you guys a little preview of what A does, but let's just go ahead and go back over that. Let me see. Let's go. So first things first. A, just FYI, A is responsible for changing two things. You have to look at the number, the value of A separately. A can either, if you increase the actual number, it does something different than whether it's a different sign. So let's just look at the number first of all. This is my parent function right here. Make it dotted. The value, zoom in, there we go. The value of A is 1, my y-intercept, my value of C is 0. That means it's crossing at 0, 0, nothing has happened to A, okay? So we have what A is the value in front of x squared, just so you guys recognize where to find it or where you are supposed to look for it. Let's go ahead and write whatever is in front and behind that A. And A is currently the number 1. So we're going to try to figure out what happens to the parabola if it increases. So if it increases, is it going to be more, greater than 1, or less? If we increase that number, it's going to be greater than 1. Greater than 1. Okay, let's see what happens to that parabola. Ready? If I go from the number 1 to the number 10, I'm increasing in value. So what's happening to my parabola? It's getting skinnier. It's getting skinnier. Say the bottom half of this rubber band. Should I just increase the brightness? I don't know. La, la, la. Where's my brightness button? Oh no. Let me go down. Wrong button. All right. Say the bottom half of this is my parabola. And if I'm getting skinnier, if it's getting skinnier, what's happening? It's getting closer to becoming what type of line? Not parallel. You're only looking at the bottom, a vertical line. A vertical line. So that means, or the phrase that we actually, the term that we actually use in Algebra 1 is called a vertical stretch, because the skinnier that it gets, the closer it gets to becoming a vertical line. We're going to write both phrases or both terms. It will get narrower. For those of you that don't understand or don't know what the word narrower means, we're going to use the word skinny. I'm going to put it in parentheses. I don't know why it zoomed in so much. It means it's getting skinnier. But the phrase or the term that they use on the STAR test is a vertical stretch. Vertical stretch. And I want you to highlight that whole phrase, vertical stretch. That's the terminology that you should be looking out for on the STAR test. Okay. Now, if we're decreasing in value, that means that that number is going to be less than 1. But in this case, I said that the sign, whether A is positive or negative, affects the parabola differently than the number itself. So when I say a smaller number than 1, we're talking about any number between 0 and 1. What kind of numbers do you find in between 0 and 1? Decimals or fractions. Decimals or fractions. So I'm going to write it really small. I'm going to put these decim or fractions. Decimals or fractions is what we're describing when we say numbers between 0 and 1. Okay? So if increasing the value makes it skinnier, what do you think decreasing the value is going to do to the parabola? Make it wider. So let's take a look. As I'm decreasing, notice how that parabola is opening up. If I continue to decrease, what kind of line do you think it'll create? A horizontal line, meaning that we are stretching it horizontally. Horizontal stretch. Okay, so it is getting wider. Not fat, it's fat. I was going to write the word fat. It's making my parabola fatter. Okay, so it's getting wider. We use a term, horizontal stretch. Horizontal stretch. And I always like to think about it this way. Fractions make you fatter. Fractions make you fatter just because they both start with a. Nothing to do with anything else. Okay? Now, if my value of A is positive, and if it's negative, it's going to have a totally different effect on the parabola. It will have a totally different effect on the parabola. So let's see what happens. Ready? All right, my value of A is 1. What happens to the parabola when I change it from a positive 1 to a negative 1? It flips. Most people use the term flip. Yes, it flips. Think about whenever you're standing at the edge of a lake or at the edge of the pool and you see your what? Reflection. So that is the term that we use, or the phrase that we use in algebra, is a reflection. Now it's flipping, it's reflecting over which axis specifically? Over the x-axis. Over the x-axis. Our x-axis is this one, and it's flipping upside down over the x-axis. Now that is something very, very important to remember, okay? So If it's a positive, if A is positive, if the number in front of x squared is positive, it's going to open up. The top part of my parabola will be the open. It'll create a U shape. But if it's negative, if the number in front of x squared is negative, it'll flip or it'll reflect upside down. Opens down. Now we're actually going to write that phrase that they use on the STAR test. Reflects over the x-axis. Reflects over the x-axis. Super, super important to remember, because half of the answers on the STAR test, if it deals with reflection, if it has to do with reflection, half of the answers on the STAR test are going to say that it reflects over the y-axis just to trick you. But we don't see a reflection over the y-axis at all in Algebra 1. Do not see that at all. I am going to show you what a reflection over the y-axis looks like, though, just so you know. Okay, so if I'm going to have a reflection over the y-axis where it flips from this side to this side or this side to this side, what's happening to the equation is you are switching x and y values. So it's x equals y squared. We don't use this formula or this equation in Algebra 1, but this is my parabola side by side or laying down. If it reflects over the y-axis, it would look like this, where it flips over the y-axis. Okay? We don't see this in Algebra 1, but you will see it as an answer choice, so just be careful with that. The value of C. We said that C is our what? It is our y-intercept. There is no special name for the value of A, but there is one for C, so we're just going to go ahead and write that in. And you usually find C at the end of the equation, where it's the number that's added to the very end. It could be added, it could be subtracted, but that number starts at 0. So if we increase the number of 0, meaning if it's greater than 0, what do you think is going to happen to the parabola? Okay. Let's take a look. A is 1, C is 0. If I increase the number from 0 to 10, what happens to the parabola? It just moves up. A lot of students tend to say that it's getting smaller, but it's not technically getting smaller. It's just that my screen doesn't open up that much. Okay? It just moves up. So the phrase or the term that we use in algebra or on the STAR test, they're going to call it a shift. Those of you that know how to drive manual drive stick, what do you call that? What do you call the shifting gear, right? So it shifts, and which way do you move it? Up and down. A little bit. Most of the time you're going up to 1, reverse, whatever. Shifts, you shift it up. So if I make this, or if the value decreases and it ends up being less than 0, what do you think is going to happen to my parabola? It's going to shift down. Do you think it's going to flip it when it changes to a negative number? No. The value of A is the only one responsible for flipping it. C is a y-intercept. So if C is a negative number, if C is a -1, it moves down to -1. If C is -2, it moves down to -2. C is only responsible for the shift. It shifts your whole parabola up or down. So shifts down. It moves the whole parabola up or down. That's all C can do. A can do two things. It's responsible whether it gets skinny or fatter, but also if it reflects or not, based on whether it's positive or negative. Okay? So all of our examples here in this foldable or in this lesson are going to look similar to this. We are going to be given a a problem, but it's going to be in paragraph form. We're going to create an equation, but we're also going to practice switching it over to function form, just because on the STAR test, they've gotten in the habit of using f of x instead of y equals. So I'll teach you how to do that. Now, in this one, in this equation, y is equal to 3x squared plus 2, what two numbers were changed? Because remember, your parent function is y is equal to x squared. So the value of a was changed to the number 3. And the value of c was changed to the number 2. This plus 2 represents c. The 3x squared represents a. Notice how they just skipped over bx. They will do that. They can do that. Okay? Now, when you have your graphs, most of the time they will give you a dotted and a solid line, especially when we're talking about transformations, where we're talking about the changes. When you get a dotted and a solid line, the dotted line will always represent f of x. It will always represent your first function, f of x. It will always represent the parent function. So I like to go in and label it f of x. Now we know that the parent function is equal to x squared, y equals x squared. But we also know that f of x equals and y equals are the same thing. Now the solid line, most of the time when they make these types of changes, they're going to name the new equation or the new parabola, they'll name it g of x. Sometimes they'll use h of x. And most recently, I have also seen p of x, n of x, and of x. All of those can be named my new parabola. Okay? Now, the most easy, in this one, let's just go ahead and name it g of x. Let's just name the new one g of x. So I'm going to put g of x right next to my solid line. G of x. So we're going to write the new function. G of x equals. Now, one of the easiest changes to identify or to be able to physically see is the change in c, the change in the y-intercept. My y-intercept for the parent function is 0, and the new y-intercept is what? 2. So what happened? It went in what direction? It shifted up 2 units. It shifted up 2 units. And that is because 2 is greater than 0. It starts at 0, moved up to the number 2. If 2 is greater than 0, it's moving up. What else happened to my parabola? It got skinnier. Notice how it's moving inwards. Now it looks skinnier than what it originally was. If it gets skinnier, we call that what type of stretch? It's a vertical stretch. And we get a vertical stretch when we have a number greater than 1 or a number bigger than the number 1. Now, the new function, they would write this as, bless you, 3 f of x plus 2. And I'll be able to show you in the next example why it looks this way. But I feel like I've covered enough on this problem for now. Ready? All right. Let's move on to number 2. Now, this is the way these problems are going to be worded. It says the graph of f of x is equal to x squared is shown on the grid. F of x equals x squared, that is my original function. That is my original parabola, the dotted line. So I'm just going to write original here. Just so you guys know that it's original, but from then on, I'm going to just use the number 1. It's always a dotted line, f of x. Go ahead and label it on your graph, f of x. Now it says function p, so we changed it to what? P of x. Function p is in the form of ax squared plus c. And they will give you either the value of a or the value of c or both. It says if the value is C is 2, that is important information. Write a statement about the relationship. So what we're going to do is first, we're going to write it in y equals form, and we're going to practice changing it to function form where you see that P of X. All right, let me go ahead and label that solid line, P of X. That way you can go ahead and get an idea of what's happening to the parabola. Okay? All right, in y equals form. In y equals form, what number or what value did they give us to switch, to change? And what variable is that? So I'm going to go ahead and highlight C. This is the only number I'm changing. They didn't give me a value for A, so that means I'm not going to put anything in front. So we're going to have y equals x squared, and if it's a positive 2, plus 2. X squared plus 2. And that is the new equation. But sometimes they also want us to write it in function form, or they'll give us answer choices in function form. And this is how they'll write it. But first, you need to understand. Equal means the same, means identical, means I can always switch this x squared with an f of x, and it'll still mean the same thing. Just like I can switch f of x with y equals. These are identical. They are representing the same exact parabola. So when they write these equations in function form, they write the brand new name of the equation, which is P of X. We changed it from f of x to P of x, and then they're just going to switch that x squared. They're going to substitute it with f of x plus 2. Remember, f of x is identical to x squared. So they substituted the x squared with f of x, putting the brand new name here on the left side of the equal sign. And we'll see this plenty of times. Okay? These two are considered the same. They are identical. It's just changed out. It's switched out, substituted. Now, the only number that we ended up changing was which one? The number 2. Number 2 is representing what variable? C. Okay? C is 2. Now, where does C start? Starts at 0. So what is 2? Is 2 less than 0 or is 2 greater than 0? It's greater. So what is the actual change? If it's greater than 2, what's going to happen? And what term do we use? Shift. Shifts up 2 units. And with the shift, that's the only one I'm actually going to ask you to write the number. Okay? Units means the number of boxes. It moved up 2 boxes. Okay? All right. Example 3. That should be on the right side of this. That's down here. Here we go. F of x is equal to x squared is my original function. Put a 1 there. That's my dotted line. You could label that on the graph as well. We're going from dotted to solid every time. Dotted to solid. We changed it to function g. Changed it to the function g of x. They're giving us which value? A. So the only number that we're changing is the number in front of x squared. It says the value of A is what? -1. So written as in y equals form, how would you write that equation? Y equals what? -1 x squared. Now, do you think they'll use that that number 1 in the answer? No, so it would just be written as y equals -x squared. You're never required to actually include the 1, but you are required to understand that it's there. Okay? Now the name of my new function is what? G of x. G of x. Equals. Now, what doesn't get replaced is that -1. That -1 will stay the same. X squared is going to be replaced with what? F of x. We will have an example where it's not. And once again, you're not required to include that -1. You're required to understand that it's there, but not to include it. So the actual answer choice will look similar to this. G of x is equal to negative f of x. I'm just trying to get you guys used to seeing it in this form because they're using it more and more every year. Now, the only number that was changed was -1. Now, understand, A already is the number 1. If I go back to the front of my book, A already is the number 1. So technically, the only thing that changed was what? The negative. So the only thing that happened is what? That it what? Reflected. Where's my, here it is. So a negative on the A, on the value of A, is going to reflect over the x-axis. And I want you to highlight that, that word, x-axis. That is the one word that you need to be looking for, especially looking for, because half of your answer choices are going to say y-axis, just to trick you. Next one, number 4. All right, f of x is equal to x squared, still seeing the same thing. This is my original function. This is my first parabola, my dotted line, f of x. They want to see what happens. They want us to see what happens from dotted to solid. I'm not switching back and forth anymore. All right, so what numbers do they give us to change? They give us the value of a, which is -3. What else do they give us? They say C is 1. So we are going to change both the front and the back of that x squared. We change it to the function h of x right here. So written in y equals form, how would you write this? Y equals what? What do we change in front of the x squared? -3 x squared plus 1, correct. -3 x squared plus 1. That -3 represents A. A is always in front of x squared. The plus 1 represents C. Okay, let's try writing this in function form. What is the name of the new function? H of x. So h of x equals. -3 will stay the same. X squared will be replaced by what? F of x. And bring down the plus 1. So to describe the transformation, we're going to have to describe 3 different things. The negative is a different type of transformation than having that 3. And then 1 obviously is separate. But negative and the 3, you have to view those separately. A is responsible for 2 totally different transformations. First of all, what does the negative do to the parabola? It reflects. Negative. The negative reflects the parabola over what? Over the x-axis. Once again, highlight x-axis. All right, A also changed or is switched to the number 3, not 1. H switched to the number 3. And how does 3 compare to the number 1? It's greater than 1, so if A is greater than 1, what will happen? It will get what? Skinnier, narrower. You can also see that looking at the graph. Narrower. And we use the term vertical stretch. Okay? We also are given C, the value of 1. How does the number 1 compare to the number 0? It's greater. So if that is greater than the number 1, greater than the number 0, what happens to the parabola? Shifts which way? Shifts up 1 unit. It shifts up 1 unit. Questions so far? All right. Number 5, f of x equals x squared. We're still not changing. Most of the time, 99 out of 10 times, they're going to use f of x as the dotted line, original. I've seen only one time where they didn't. So we're going to practice that as well. It changes or it switches to function g of x. What number did they give us to change? Just a. A is 3. So we're only going to include or change the number in front of x squared to a number 3. How would you write this in y equals form? Y equals 3x squared. Y equals 3x squared. All right, Anthony wants a turn. What's the name of the new function? Anthony, they're waiting on you. What's the name of the new function? G of x. Do I do anything with the 3? Okay, but I do switch x squared with f of x. There it is. The number in front of f of x makes it skinnier or fatter. Because we changed a to a number 3, how does 3 compare to the number 1? It's greater. And what does a number greater than 1 do? Makes it narrower, which once again, you can also see by looking at the graph. Narrower, vertical stretch. Vertical stretch. Questions? Basically, so you're always going from dotted to solid. This one moved in. It didn't shift, but it did move in. So that means it got skinnier. Okay? All right, example 6. Let me find it. I want to say it's down here. Yeah. All right. Now, the first equation that they give us, or our x squared equation, is what? G of x. So this time they did use a different one. And g of x changed to what? H of x. They give us 2 different values, so please don't write function form until I show you how to do that, okay? What values do they give us? A is what? A is 1/2, and C is what? 2. Writing this in y equals form is still going to stay the same. So how would you write this? Y equals what? 1/2. X squared plus 2. 2 is our value of C. 1/2 is the value of A. Writing fractions in function form, this is where it is different. Now, please don't ask me why they chose to write it this way. They just did. I just noticed a pattern, and I'm going to show you that pattern. What is the name of the new function? It changed to h of x. It went from g of x to h of x. Okay? Now, when you're given a fraction, for some reason or another, they don't use the old g of x. They don't write 1/2 g of x plus 2. What they do is they put this variable of x right here at the top with the 1, make in parentheses, so it's like writing 1x over 2, closing it, putting the squared, plus 2. I don't know why, that's just how it's written on the STAR test. But as always, would they include the number 1? No. So the answer choice would actually look like h of x equals x over 2 squared plus 2. H of x equals x over 2 squared plus 2. That is for fractions. That only applies for fractions. But we did change 2 different numbers. We changed the value of A and the value of C. Okay? The value of A is 1/2. How does 1/2 compare to the number 1? It's less, it's smaller. So if it's smaller, what's the transformation? It's getting fatter, which we use the word wider. or what? Horizontal stretch. And horizontal stretch is the word or the phrase that you'll see on your assignment, not stretch. There should be a T there in front of. All right, the value of C. The value of C changed to the number 2. How does the number 2 compare to the value, the number 0? Greater. So if it's greater, what happens to the parabola? It shifts which way? Up. It shifts up 2 units. Last one. Ready? Okay. All right, number 7. This is the one I messed up on my notes. So we're going to use f of x equals x squared. The graph doesn't match with the words. So f of x equals x squared. And it's used to create the graph of n of x. So we got to fix this. It should say f of x, n of x. No, yeah, n of x is there. F of x and no, y'all say g of x, right? So write n of x. I'll just go ahead and scratch it. I thought I fixed everything, but I didn't. So what 2 values did they give us to change? A is -1/4 and C, change it to a +2. Currently it has a negative in front, just make it a plus sign. +2. Because the graph doesn't match that -2. Ready? All right, how do I write this in y equals form? Plus 2. 2 is my value of C, -1/4 is my value of A. Okay? We have to be careful because we do have a fraction. The new equation is n of x. The new function is n of x. The negative is going to stay on the outside, but how do I write the inside of this? X over 4 squared plus 2. X over 4 squared plus 2. Once again, you're looking at 3 separate or 3 different changes because A is responsible for 2 different things. Okay? The negative. The negative does what? It reflects. It reflects specifically over what? Make sure you highlight x-axis. It reflects over the x-axis. The value of A is what? 1/4. How does 1/4 compare to the number 1? So what happens to the parabola? It widens wider. And what's the phrase? Horizontal stretch. Okay? And then C. C is 2. How does 2 compare to 0? Greater, it's larger. So what happens to the shift? Shifts up 2 units. When in doubt, use your chart. When in doubt, use your chart. Not yet. I'm going to show you how the assignment looks like. That way you guys aren't super confused. It's actually the assignment is much simpler than the notes. Yes. The notes are a little bit more in depth than the assignment. Not yet. I literally just said that. You asked and I said. Okay. The back side of this assignment is going to be multiple choice. It'll have your phrases, horizontal stretch and shift. Okay? So just make sure you're looking at that carefully. The front side is the one that sometimes can be a little confusing. They're asking for the value of K. If you look at the new function, K is located where? Behind or in front? Behind f of x. So K right here is representing what? The value of C. Look down here. The K is in front of f of x, so K here represents what? And so we're talking about what? The stretch. Is it getting skinnier or fatter? Okay. So you're just going to tell me how many did it move up or down, or how many did it stretch? Okay. All right.